All right, hey gang, just wanted to get us started with this next section on 4.6. Now this section deals with isosceles triangles. Now if you remember, we talked about isosceles triangles earlier this year, and I'm sure you've covered them in previous years as well. But what an isosceles triangle is, I'm going to try to draw one fairly accurately here, is this, as my pencil breaks, it is a triangle with two congruent sides. All right. Now, the special part about what we have here with an isosceles triangle is this. I'm going to take us back actually to the equilateral triangle. When we talked about the equilateral triangle at the beginning of this year, a little longer than I want it to be, we said, hey, all three sides have to be congruent. But we also said that the equilateral triangle was also equiangular, so we end up having all three angles congruent. Okay, 180 divided by 3 gives us 60 degrees for each of those. And so three angles congruent, three sides congruent. The reason why this is because the side opposite the angle influences that angle. So if you can think about it this way, if this side continues to decrease in length, what happens to the angle? Well, it gets smaller, right? If this side over here increases in length as these two sides remain the same, this angle gets bigger, okay? So as a result, what I want you to know is that these sides and these angles, they have a relationship to each other. They work together. And same thing with these two, and same thing with these two. So with three congruent sides, we have three congruent angles, right? So if I come over here, I have two congruent sides. So the question is what about the angles? Well, you have two congruent angles as well. And those two congruent angles are going to be opposite those sides. And so I'm going to mark those angles congruent right there. Now, this is called the base of an isosceles triangle. This is called the vertex of an isosceles triangle. These sides that are congruent are called the legs of your isosceles triangle. And these angles that are on the base of the triangle, the non-congruent side, those are called your base angles. So we have a base angle here, and we have a base angle there. Okay, so with that being said, let's actually take a look at some of the possible problems I could give you, okay? So when we take a look at the paper here, as I read through this, property of an isosceles triangle, an isosceles triangle has two congruent sides called legs. We just talked about that. The angle formed by the legs are called the vertex angle. Okay, so B right here would be the vertex angle because these two sides would be the sides that would be congruent. Okay, the other two angles are called the base angles. Now the base angles are opposite those congruent sides, and so these angles are congruent to each other. You can prove a theorem and its converse about the isosceles triangle. So if two sides of a triangle are congruent, then the angle opposite those sides are congruent. Okay, that's called the isosceles triangle theorem. Now the converse is when we go from the angles to the sides. Okay, so if two angles of a triangle are congruent, then the sides opposite those angles are congruent. Okay. So I'm just going to, you can look over the examples there. I'm going to quickly just kind of run through these to make sure you're understanding what's being talked about when it comes to the isosceles triangle. As I do that, let's just look at the page here. Looking at numbers 1 through 6 here. Number 1, in all of these problems, whether you have congruent angles or sides, I want you going ahead and drawing an arrow to the opposite angle and showing those to be congruent. Okay? Super easy, so I know that this is also 2x up here. So from here, if I wanted to come up with an equation to solve for x, the sum of those three angles has to be 180 degrees, okay? I'm not worried about the answer right now. I know you guys can solve for x, but make sure you know how to come up with the equations, okay? Here, when I have congruent angles, I'm going to point to the sides opposite and say, hey, they have to be congruent. So the equation here to solve for x is going to be this right here. Okay. This one over here, drawing an arrow to the opposite angles. So these are both 3x. You could do this, 3x plus 90, because that's the sum of all three angles equals 180. Or this is actually a special right triangle. And both of these angles are going to be 45 degrees. It's a 45, 45, 90. So you could have also done this right here. But if you didn't realize that, you know, the first equation is plenty fine. You'll still get the right answer. As you look at numbers 4, 5, and 6, again, I'm going to point to the angles opposite here. And I'm going to go ahead and mark those guys congruent. So I've got two angles. You can write it out in expanded form, meaning 6x plus 6 plus 6x plus 6 plus 2x equals 180. Or you could go ahead and say, hey, there are two angles that are 6x plus 6. The third angle is 2x, and their sum has to be 180. Okay? Again, very similar to number 3 up above. You can either do, hey, there are two angles of 5x plus a 90-degree angle is equal to 180. That'd be one way you could write it out. You could also say that 5x is equal to 45, because as we talked, it was a special right triangle, 45, 45, 90. Okay? In this one, you've got two angles that are both x, a third angle that's 3x, and their sum is going to be 180. Okay? So again, I want you to get in the habit. I can't stress this enough. Please get in the habit of going ahead and drawing those arrows to the opposite angles and marking them congruent. It's really so simple. Okay? So let's take a look at the back side here. Oh, two-column proof. Okay, so let's go ahead and work through this one real quick. Angle 1 is congruent to angle 2. I'm going to write down that that is a given. Okay, we know that to be true. Now, after that, I'm looking at the picture right here, and I'm going to say, hey, angles 2 and 3 are congruent to each other because they're vertical. So I'm going to say angle 2 is congruent to angle 3. Vertical angles theorem. Again, this is a concept that's in a lot of these proofs, so I hope that you're getting it down how to recognize the vertical angles. Okay? Now, from there, if I look at the next step, if 1 is congruent to 2 and 2 is congruent to 3, I know 1 is congruent to 3. So I'm going to define that. 1 is congruent to angle 3 by the transitive property. Okay. Now from there, if those two angles are congruent, what do we know about BC and AB? Well, they have to be congruent, right? So I'm going to say that AB, I'll do it the same way they say it in the picture there, is congruent to CB by the converse. Now remember, we're going from the angles to the sides of the isosceles triangle theorem. Okay, the converse of the isosceles triangle theorem. So I hope that makes sense there, guys, as we work through that. Now, the next section says this. Properties of an equilateral triangle. Equilateral triangles have 3 congruent sides. We already talked about that. The isosceles triangle theorem leads to 2 corollaries about the equilateral triangles. A triangle is equilateral if and only if it is equiangular. Okay, we talked about that, how all 3 sides lead to all 3 angles. Excuse me. Oh, I should do that, sorry. Number 2, each angle of an equilateral triangle is 60 degrees. Now again, remember, if you have 3 congruent sides, leads to 3 congruent angles. If I take 180 divided by 3, each angle is 60 degrees. Okay? So as I look at this, say number 1 down here, again, I'm getting in the practice of pointing to my congruent angles here. All 3 angles are congruent. You could go ahead and say, hey, there are 3 angles that are all 6x. So the equation would be 3 times 6x equals 180. That's one way to do it. Or, as we talked a moment ago, each of these angles are 60 degrees. So 6x equals 60 would be another way to go about doing that. Here, I'm going to go ahead and point to all the congruent sides here. So this side, and this side are all congruent. So 6x minus 5 equals 5x would be your equation to solve for x. Okay. For number 3, again, there's lots of different ways you could write this down. Could do it that way. Or as we talked a moment ago, one of these angles is going to be 60 degrees, which would be fine there too. Okay. If I go to the last page, okay, on the last page, what we have, let's scoot that up just a bit. Okay. Again, I'm going to go ahead and say, hey, these side lengths are all congruent because all the angles are congruent. And so I'm going to go ahead and say 4x is equal to 40. That one wasn't very hard because it already kind of showed it to you. The next one, this is 60, and these two have to be congruent. So if I go ahead and take 180 minus what's there and divide that by 2, that should give me the measure of each of the other angles. So in this case, all of them are 60, so this is an equilateral. All these are congruent. All these angles are congruent. And so as a result, I can set these two equal to each other. Okay. Lastly, you can tell the way the angles are marked. These are equal. So we have that right there. Okay. Number 7, the proof down here. We'll quickly walk through this one as well. Okay, I'll just go ahead and write down ABC, the triangle, is equilateral. Okay. Now, if it's equilateral, what does that mean? Well, that means that AB is congruent to BC, which is congruent to AC. I gotta remember where I was at. So yeah, those segments are all congruent because remember, in an equilateral triangle, all segments are congruent. So I'm going to put down by definition of equilateral triangle. So as I mark this out, I'm just going to mark those two sides congruent because that's really what is going to help me prove the triangle's congruent if I need to do that. So I'm going to go ahead and do this angle here is then congruent to this angle here. And the reason that is because of the isosceles triangle theorem. If this side's congruent to this side, these angles have to be congruent. So I'll say angle A is then congruent to angle C by the isosceles triangle theorem. Okay. Now I'm going to go ahead and take a look at angles 1 and 2 because here it says BD bisects this angle. Okay. So I'm going to go ahead and put that part of the given down. And I'm going to ask myself, what does that mean? If this segment is bisecting this angle, well, that means that these two angles have to be the same measure. So I'm going to go ahead and say that angles 1 and 2 are congruent, let's see here, by the definition of bisects. Okay. Now, if you think about this for a moment, we don't have to prove the triangle's congruent. We do have congruent triangles by angle, side, angle. So you could go ahead and say angle, side, angle, and then prove these two angles congruent by CP, CTC. But I could technically go right to this point right here and say angle ADB is congruent to angle CDB. Okay, these two angles are congruent by, do you remember it? If these two angles are congruent to these two angles, don't the third angles have to be congruent as well? The third angles theorem. Triangle, yeah, the third angles theorem, I think is what we called it. Third angles theorem. Okay? So with that being said, again,